Hello everyone, welcome back. In this video, we are going to learn how to write functions. Now, as you may recall, functions allow you to pre-write a block of code which can then be reused as many times as you like. So here is a simple example of a function which is going to take a variable and square it. So we're going to say def for define, square, which is the name of the function, x, which is the input parameter. And then based on what we've learned about for loops, you're not going to be surprised by what I type next. It is the colon. And then we type in an indented block. And I'm going to type in y equals x times x. I could have written x powered to 2, but I had to write x times x. Then we are going to type in return y. So there's our function. And if we want to go ahead and use it, we can run the square of 3. And unsurprisingly, out will pop 9. Now, a few things to note is the things we didn't have to do. We didn't have to say what type of variable x was. We did not have to say what type of variable y was. So this means that if you input an int, the above function can return an int. And if you input a float, the above function will return a float. So it's like the function is automatically overloaded. So for example, if we square 1.414, that will return 1.999 because 1.44 is very close to the square root of 2. And similarly, if we square 2.0, we're going to get 4.0. But if we square 2, we just get 4 with no 0. So this works really nice and everything is automatically overloaded. On the other hand, it can only do so much with the automatic interpreting thing. So if you try to square cat, it's going to tell you, well, what the heck does cat times cat mean? This is just going to give us an error. It says type error, can't multiply by non-int of type str. Okay, so that's bad. Don't square your cats. So in our next example, we are going to create the function y equals 2 times x. So we're going to write def double x colon input y. And we could write y equals 2 times x return y, but it actually might be a little bit easier. We're going to save us one whole line of code and just return 2 times x. And now the great thing about doubles, this is going to work well with both ints and floats. So double 3, and we can double 3.0. This will return us 6 and 6.0. And this actually, quite surprisingly, it actually even works with strings. So now if we try to double our cat, we're going to get a cat. Because it concatenates cat with itself twice. And going even further, it actually will even work with lists and with tuples, where it's going to, again, like with strings, it's going to act by concatenation. So if we have L is equal to, okay, we got a list. Let's go with A, B, C. If we double L, we get ABC, ABC. If we have a tuple named T, which has 1, 2, 3, we can also double T. On the other hand, this does not work with dictionaries or sets. So if I tried to create my best dictionary, which will be D equal to A colon 1, B colon 2, and we try to double the dictionary D, this is not going to work. And it wouldn't work with sets either. And the reason why it doesn't work with this is that it concatenates, which means it puts the first element of the second copy right after the last one. So it's very important that the items go in order for this function to be well defined. And dictionaries and sets have no order, so when I tried to double the dictionary, then it was not able to work. Okay. So doing the basic things with functions is quite user-friendly. Python is a dynamically typed language, which means you typically don't have to say what type of variable things are, and it will automatically guess things for you. And in the spirit of automatically trying to guess things for you, the way that scope works is also meant to be very friendly, but the friendliness can actually come back to bite you if you're not careful. So to explore scope, let's do the following example. This is not going to work. I have defined a function called printx, and I just type out printx. And okay, actually, if I just try to type that, that is fine. But if I try to call it, this is going to run an error. And the reason this is going to call an error is because I've never defined what x is. But that's actually the only reason that this called an error. So if I go down here and I write that exact same code, but I go up before and I type in x is equal to 3. Now this works fine. So global variables are automatically passed into functions if there is no local variable to override it. On the other hand, if there is a local variable to override it, so say we have f equals 7, def print x, and now we create a new local variable inside of the function. This is going to print 7. However, after the function is over, let's make the global x 3 and the local x 7. So this is going to print 7 when we run the function. But now, after the function is over, we are back to the global x. So if we try to call x, out pops a 3. On the other hand, if there had never been a global x, this function here actually will still work, but then there won't be a function after it's defined. So for example, let's just delete x. So I'm going to delete x. And now if I try to print x, this is going to throw us an error because I've deleted x. There's no longer an x. It says name error. There's no longer a thing called x. So now that x is deleted, just get rid of that nasty error message, we can try to rerun this function and see what happens. So let's just copy it over. So we've got a function called def print x. And we defined x inside of the function, so we print x. So everything works fine. However, now in the global scope, there is no longer an x. So if I try to run this x, it is going to throw me an error because the x was created only in the local scope and it no longer exists in the global scope. Okay, let's leave this here for your notes, but comment it out. I don't like having error messages displayed, so I like to get rid of them. Okay. So the rules for scope is that the function has access to global variables inside of the function unless you have a local variable with the same name. And I should point out that this is technically allowed, but it's usually a bad idea to rely on the globally defined variables when writing your function. Another thing to note is that if you type x equals inside of the function, it will create a new variable inside the function, a local variable called x. And local variables are deleted after the function is done, which we just saw in the example. So the fact that you can access globally defined variables leads to some potential pitfalls. So let's explore this with our function, which we named BadFun. So we've defined def, BadFun of t. We said y is equal to x plus 2, return y. So one thing to note is that we never actually use the input variable t. But if there is a globally defined x, BadFun is going to work perfectly fine. However, what's really insidious about this is that this depends on whether or not there is a globally defined x. So if we delete x, and now we try to call BadFun of 5, this is going to give us an error. It's going to say, name error, there's nothing defined x. Name x is not defined. So you're almost never going to write a function like BadFun on purpose, but you might on accident. Probably what you meant to write was something like this. def goodfun t y equals t plus 2. Return y. And now goodfun is going to work greatly whether or not you have a y in the global scope or not. So we have goodfun of 7. This is going to give us a nice 9. And if we go ahead and we define t is equal to 3, and we type goodfun of 7, this is still going to give us 9. But the global t is still exactly what it was before. So let's actually print this in a new cell. Our global t is still equal to 3 because only the local t was changed. And as we already noted, BadFun is something which can cause an error. And what's really insidious about it is that it may work or it may not work depending on whether or not there is a global x. And this can make it really hard when you're testing out your code to find your errors. And the worst thing that a program can do is to not work and not let you know that it's not working. So BadFun is a really nasty type of error that you really need to be careful to avoid. The second thing to warn you about is that it actually is possible to modify a global variable inside of a function. So we have a nice list called 1, 2, 3, and we write a function named sillyprint, which aims to print out L, and then also print out the letters A, B, C. So we could write L.append A, L.append B, L.append C, print L. So now if we just run sillyprint, on L, this is going to look like it worked great. It printed out 1, 2, 3, A, B, C. And since we are a very silly printers, that is what we decided we want. So what's the problem? The problem is that if we try to print out L, we have modified the global variable inside of the function. And usually this is a bad idea. There's no rule against it, but I strongly discourage you from it. Do it as little as possible. It will usually cause problems and very rarely be what you want to do. So here is a better way. So instead of writing sillyprint, we are going to write better sillyprint. So this code here is exactly the same as before, but it is now better sillyprint. And the only thing we're going to do is we are going to say local L is equal to L.copy. And then we are going to, and this makes local L is going to be a copy of L. And then we change all of these L's to local L's. And let's go ahead and reset L to what we want it to be, which was just 1, 2, 3. And now, if we do better silly print on L, this is going to do what we want, but we did not modify the original function. So when you pass a mutable object into a function, it is possible to change the value of the mutable object inside of the function. This is usually a bad idea, and the way you can avoid this is by making a copy. Alrighty. So the next couple of things we're going to discuss for this video is default values and keyword arguments. So here's a function which is going to print a message possibly multiple times. def print multiple times message n. And we're going to say for I in range n, print message. So now let's run this function to print woof 3 times. So if we do print multiple times woof, comma 3, it's going to print out woof, woof, woof. Okay. Now what we're going to do though is we're going to add in a default value for n to make it so that if you don't specify what n is, it's only going to bark once. So now if we just type in print multiple times woof, and we don't tell it what n is, it's going to automatically assume that n is equal to 1, because up here we specified a default value, n is equal to 1, and so it's just going to print woof. Now, particularly in the second half of this course, we are going to be using pre-written functions to do all sorts of really cool stuff related to data visualization, data manipulation, and other things. And a lot of these functions have tons and tons and tons of arguments. And it can be hard to remember what order these arguments are listed in. So a good way to do this is just to use the keywords when calling the functions. So we can do print multiple times, n is equal to 3, and message is equal to woof. And even though that we've got n first and message second, where up here message came first and this came second, since we use the keywords when calling the function, this is going to work the same way as in this cell up here. In particular, it's going to bark 3 times. Woof, woof, woof. So this is all great. So the only thing you need to be careful about is that keyword arguments have to come after positional arguments. So if we do print multiple times, woof, comma, n equals 3, this is going to be fine. Woof, woof, woof. Sorry, I'm a little bit tired of barking. But this is going to cause you a little bit of a problem, where if you try to do print multiple times, message equal woof 3, this is not going to be happy. Where are you going to get yelled at? Okay, like I said, we got yelled at. All right, so that's it for this video. We will learn more about functions in our next video.